Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's get started on today's lesson, which is 8.2.2, inference from random samples. Okay, so let's talk about what an inference is. An inference is an educated guess based on the analysis of data to draw a conclusion about a situation. So when we have like data and we are trying to figure things out by reading the data, there are certain ways, certain things you can look for, you know, finding the average, finding the median, putting information into box plots and histograms, and you can draw some conclusions by looking at the data once you've organized that data. So that's basically the idea of making an inference, and that's what we're going to be doing today and answering a few questions. Now, I am going to try and go through this lesson fairly quickly because I know yesterday's went super long, and I'll pause a few times, and there's still going to be a fair amount of work to do, but I'm not necessarily going to go question by question and answer every single one of these questions with you. We'll just get to the main big points. So here, I'll just kind of summarize what this says. In previous lesson, you studied the randomness of various sampling populations. Now, if you wanted to know the average height of a tree in the forest, you're not ever going to be able to measure every single tree, add all their heights together, and then divide by the number of trees in the forest. It's just impossible. What you would do is you would find a random sample of trees, you know, maybe pick 10 or 20 or 30 of the trees and measure them and find out what their average is. And of course, you would hope that that was a good representative sample of all the trees within the forest, and it probably would be. So if you measured 10 trees and found the mean, you would get the number that describes those 10 trees, but probably also can be projected onto, you know, we use that to generalize the average height of the tree in the entire forest. So we're going to do something similar, but we're going to do it with the size of robins. And so for this, normally what I would do is I would pass out a worksheet to you and your groups, and you would pick there'd be like 10 random birds that you would pick their weights, and then we would do a study of them. What I'm going to do is I'm going to have us pick 10 random ones, and I'll do it for you. And then we are going to figure out what the mean of the sample is. And then do we want to do the mean? You guys already know how to do the mean. We don't necessarily have to do that. Let's just move on to the next part. We're going to make a histogram and a box plot in one. And we're going to use a bin width of 5 grams on the histogram, and that bin width will also serve as the number line for our box plot. Okay, so here are all of these. What is this? 100 birds here, 100 bird weights. They're all randomly put on there. I have created a stem and leaf. I don't know that this is actually right, though. I don't know if I want to do this. Here, let me pause this, and then I'm going to come back. Because those aren't going to be bin widths of 5. These would be bin widths of 10. And so I need to change this to something a little bit different. Hold on. Okay, you know what? I've changed my mind. We are going to use this. We're going to use this to help us find the data that we need for the box plot. It's not going to be the numbers that we need for the histogram, but that'll be okay. Okay, so let's do this. Let's choose, I'm going to pick a highlighter here, and I'm going to just put my highlighter over 10 different numbers. Come on, highlighter, hurry. All right, there we go. Okay, so I'm going to turn my head. You don't realize that I'm turning my head, but I am turning my head. I'm not looking at the numbers to try and keep this as random as possible. And I'm going to do this like 10 times. Okay, now I have to look. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, turning away, and there's the 10th one. All right, so this looks like it's close to that. That looks like it's close to there. Ooh, that's closer to there. All right, not too bad. So what do we have here? Creating this stem and leaf plot that I've got over here, we've got the lowest number is 40 something. There's 40, and the largest number actually is 122, but I didn't highlight that one. So let's just go ahead and let's record these in our stem and leaf plot. So we've got an 86, that goes here. We've got a 103, so that's going to go here. Another 103, interesting, that's going to go here. Another 86, wow. There's a 104, there's a 74, there is a 103 again, 3 103s, that's amazing. There is a 72, there is an 87, and there's a 73. Is that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? Okay, this is unordered. So I'm going to put these back. I'm going to put these in order. So the 2, stop it. Oh, no. You're killing me. 2's going to go there. I guess I need to take this, pick them apart. Okay, that'll work. So this will go there. This will go there. Then I just need to reverse these 2. All right, so those are in order from least to greatest: 72, 73, 74, 86, 86, 87, 103, 103, 103, 104. So since we got 10 of them there, we can find the median. The number that's in the middle is going to be the number that, what is it, 1, 2, 3, 4, 5? 1, 2, 3, 4, 5. It's going to be the halfway point between 86 and 87. What is that halfway point? That halfway point would be 86.5. The minimum is easy to find. That's going to be 72. Let's just go ahead and write that in. And the maximum is going to be 104. And now to find the lower quartile, we have to find the median of the lower half of the data. So since everything below 86.5 includes the 286s, the 74, 73, and 72, that makes 74 the first quartile. And that makes 1, 2, 3, I guess 103 is the third quartile. All right, so there's our information that we're going to need for our box plot. For our histogram, we're going to have to break this up into intervals of 5. So luckily, these guys are clustered in there pretty quickly. Ooh, what's going on down here? This doesn't belong there. Why are you there? Oh, no. Oh, well, we'll cover that up. Hold on. Can't have that. Yay, it's gone. Okay. So for the intervals, let's do the, maybe I'll do the intervals over here. So the interval for our data is going to go from 70 to 74, then from 75 to 79. Maybe it's better if I just do it this way. We've got 80, then 85, then 90, then 95, then 100, and that's all we need. We don't need 105. So the 80 goes to 84, 85 starts the new, goes to 89, 90 starts the new, goes to 94, 95 starts the new, goes to 99, and then this one's going to go from 104, or from 100 to 104. So how many of these numbers fell between 70 and 74? It looks like 3 of them did. How many of them were between, none are there, none are between 80 and 84, but we've got 1, 2, 3 are between 85 and 89, and then none, 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 and then we've got 4 here, 1, 2, 3, 4. Oh, that is some crazy data for our box plot. Oh, I hate this. Oh, well, it's the data we've got, so we've got to work with it. All right, so here is our data. This is what we're going to need for our box plots. Now let's move to here. So what I've done is I've scaled this. I'm going to change this. I'm sorry, let me pause. All right, I'm back after a little bit of housekeeping there. This is going to work out a little bit better. Let me move this guy up to there. Okay, and my OCD, there we go. Much, much nicer. All right, so what do we have here? We've got, we're going to start right here. And how many did we have that were between 70 and 75? I think we had 3 of them, correct? So let's create a box. And how do I want this to look? Let's that one. That's a nice color. So it goes up to 3. Ooh, very nice. And then the next interval we had between 85 and 89, we had 3 there. 85 and 89. And then for the last, come on. All right, that'll work. And then the last one had 4, and that was between 100 and 105. This is the worst histogram I've ever seen in my life, by the way. This is like trimodal. It's like there's 3 peaks. Where's the average going to be? It's kind of hard to tell. I'd probably do the experiment over and pick some new numbers, but I'm not going to do that. We'll just stick with what we got. So this is what the histogram would look like. And I guess the average or the mean has to be somewhere probably in this section right there, since that's the middle. Maybe a little bit closer to here. And in fact, what did we learn? It was 86.5 on the for the median, right? And so 86.5 would be somewhere around there. Yeah, okay. So yeah, so the median, the middle is going to be somewhere in there. Let's take a look at what the box plot would look like. So with the box plot, I'm going to create this number line across the top. Actually, I don't want that line. I want this line. What was the minimum? The minimum was 72, correct? So 72 is going to be somewhere right around here. 72 and a half would be there, so 72 is right around there. And the maximum was 104, so that's going to be somewhere around here. So I will label those 2 numbers. 72, and I'll put a little dot there. 104 is going to go right here. And our median was at 86.5. So 86.5, that was 87.5, so it's going to be somewhere around here. And the lower quartile, the first quartile was at 74, and the upper was at 103. So 72, 74 would be somewhere around here. And 103 would be somewhere around here. So I'm going to fill in this box now. Like this. I guess I have to do that other line over again, but that's okay. I'll do that over again. What was that, 86.5? We said it was going to be somewhere around here. Stop it. Somewhere around here. Okay, so there is our box plot. Do you see how our median is right here in the middle, just like we've got here? Look at our interquartile range, how huge that is. I'll label. We need to include our labels in here. So are we drawing some conclusions about this? The average weight of an American robin, according to our sample, was 86.5. But really, the true average probably is going to be somewhere in this interquartile range, somewhere between 74 and 103. Because we're not going to go through and take every single measurement of all 100 of them and find the mean. And even if that was, it's only 100. Even that's a sample. It's not the total American robin population. But we did take a random sample, 10 out of the 100 that were given. So this is the information we have. So I would say the conclusions that we would draw would be that the American robin generally weighs between 74 and 103 grams, and the median weight is around 86.5 grams. All right, on to a different kind of a problem. Cyrus plays volleyball in county-wide tournaments. He wondered what portion of volleyball players preferred plain water over sports drinks during intense games. So at his next tournament, he selected 50 random players from all the teams to ask them their preference. This is what he found. He found that 78% of them preferred to drink the plain water, not the sports drinks. So what inference can Cyrus make about all of the volleyball players in the county? Well, this was just 50 of them, but it's, hopefully it's a random representation. I would say that majority of the people, why is this locked? Stop it. There we go. A majority of the people prefer the plain water, obviously, and that's like 3 out of every 4. So that's a pretty high percent of people that prefer the plain water. What additional information would Cyrus gain if it was practical to take many samples at many tournaments in the county? Well, you could do what we did with the box plot, and you could find like that range of percents where the true average would end up being. So just like, let's go to the previous page here with the robins, where the median was here. Really, this interquartile range is a much broader kind of a middle to the data. So the robin weights would be from 74 to 103. Here, we're looking at a situation where if we had the data, we might be able to find a broader range in which the average would truly be. So, lucky for us, we actually have some extra data. So what I'd like for you to do, please pause and copy down these numbers. Then, I've already done it for you, but then put them in order from least to greatest. You have to have ordered data in order to create a box plot. So go ahead and do that now. And while you're at it, see if you can identify the minimum, the maximum, the median, and the 2 quartiles for this data. When you come back, I'm going to go ahead and pause it too. We'll take a look and see what we have if your information agrees with mine. Okay, so you're back. Do you have the same data that I have for the minimum, maximum, median, and the 2 quartiles? The minimum was 71, the maximum was 84. The median falls between these 2 numbers because there's a total of 12 numbers. And so you count in 6 from either side, and you got 2 numbers in the middle. So find the average of those 2, and that's 79.5. Everything below 79.5 brings you here. The median of this lower half is going to be the halfway point between 73 and 77, so you should have gotten 75. And then in the upper half, the 2 numbers in the middle are the same number, so that's going to be a 3rd quartile of 81. Now what I would like for you to do is I would like for you to create this number line, counting, I just counted by ones, but numbered every other one, and then plot each one of these points on the number line, and then directly below it, so we can take a look and see what the box plot looks like. Okay, you pause and then see if you've got what I've got. All right, does your box plot look like this? Hopefully it does. Now, here was my minimum, 71, so I'm going to line that up on the below the number line for 71, and I'm going to label it. This was my 1st quartile, was at 75, so I'm going to label this. My median was at 79.5, so I'm going to label my median. My 3rd quartile was at 81, so this is 81 here, and then the maximum was at 84. So the average percent of players that preferred drinking plain water as opposed to sports drink in 12 of these cases was 79.5, which was higher than the original average, which I think he said was 78%. But the true average probably falls really between 75 and 81 because you're not able to ask every single volleyball player for every single team everywhere. But there's a very good chance with this random sample that the average falls somewhere in this range. But the average for this particular group was 79.5. Okay? So hopefully after this lesson, you are getting a little bit more comfortable with taking data, putting it into either histograms or box plots, and drawing some conclusions by looking at the histogram or the box plot. So good luck on your homework. I think I got this under 20 minutes for my lesson. So it's a little bit better than yesterday. Okay, take care and good luck on the homework. Bye.
Hey, feeling good, like I should.